Hi everyone and welcome to the channel. In today's video we're going to be taking a look at my submission for the overclocking build-off. Now for anybody who doesn't know what that is, it's a fun little thing where you put together a system to the brief of the build-off and then you make a video about it and stick it on YouTube that's showcasing all the things about the system that you've built. Now the brief for the overclocking build-off is to put together a system using whatever parts you want from whatever vintage, whatever year, but when you've put the system together you've got to overclock some or all parts of the system that you can. And I thought, well, that sounds right up my street, so why not give it a go? Now when it comes to overclocking, the first thing that a lot of people think of is the CPU. And indeed over the years there's been a lot of CPUs that are really fondly remembered as fantastic overclockers. But I feel like that'd be the kind of obvious thing to pick, and besides I'm sure there'll be a lot of other people doing the overclocking build-off who'll be using those fondly remembered CPUs in their builds as well. So I've decided to do things a little bit differently. What we're going to do is have a look through the spare parts boxes and we'll pick a CPU and some accompanying hardware for the system that's much more sort of unremarkable, wasn't really remembered for any particular reason, very sort of run-of-the-mill. We'll build a system out of that lot and overclock that instead and see what kind of performance increase we can get out of that from overclocking. So in terms of a CPU, I'm afraid that means there's going to be no 486 DX240s, there's going to be no P166 MMXs, none of the legendary Celeron 300As that we used to clock to 450 just by changing the bus speed, no Thunderbird Core Athlons, no 1.6 gig P4s, no mobile Athlon chips, no i5 2500Ks, none of them. So our CPU of choice for the overclocking build-off is going to be this. It's an AMD Duron. Now I'm doing this Duron a bit of a disservice with that introduction. It may not be one of the legendary overclocking CPUs, but it was certainly the budget-friendly overclocking CPU of its time. This particular model is a 750 MHz part and it's based on the original Spitfire core. As you can see, this one's well used. It was working the last time it was used, but that was many years ago. We can see that two of the foam pads are missing here at the bottom, but all the corners of the CPU die are still intact. Because these early Athlons and Durons didn't have an integrated heat spreader, you had to be very, very careful when you were putting the heatsink and fan on or taking it off. If you got it slightly off center or too much force on one side compared to the other, it was not uncommon for the corners of the die to crack and break off. Sometimes if you got lucky it'd keep on working, other times that'd be it, CPU killed, stone dead. Now the Duron was essentially a cut down version of the Athlon chip. The main difference between them was that the Athlon had 256 kilobytes of L2 cache, whereas the Duron only had 64 kilobytes of L2. The L1 cache was 128 kilobytes on them both. Now on first hearing that sounds like it'd be quite a performance penalty for the Duron, but it's not as bad as perhaps the figures would suggest. Now the first reason is that the Durons and the Athlons treated the cache as if it were one big lump, rather than replicating the data in the L1 cache in the L2 cache as the Intel chips did. So effectively what the Duron saw was one big lump of cache with a faster 128K portion and a slower 64K portion. This was less of a performance penalty than duplicating the L1 cache data in the L2 cache. The second reason is that the L1 cache size of 128 kilobytes was a big cache for the time, and therefore the reduction in the size of L2 cache didn't have as big a performance penalty as you might think. They used the same socket as the Athlons, which was socket A, or socket 462 as it was also known. And they used the same bus speed, which was 100 MHz, although it was effectively a 200 MHz bus as it transferred data on both the rising and falling edges of the clock signal. This meant that pretty much any motherboard that would take an Athlon would also take a Duron and vice versa. These cores were made on 180nm lithography and they were released on June 19th back in the year 2000. The price of them was significantly less than the comparable Athlons, but if you then went on to overclock your chip, you'd have a CPU that was almost as fast as the best Athlons out there, but for considerably less money. So, how are we going to keep our Duron cool while we're overclocking it? Well, just like there were some legendary overclocking CPUs, there were some coolers as well that were favourites among overclockers for keeping the CPUs cool. I'm thinking of things like the Global Win FOP32 and the Alpha PAL 6035s. These had these 60mm Delta fans on top of them and they span at something ridiculous like 6,000 or 8,000 RPM. They were incredibly loud, but they did the job of keeping it cool. There were the Thermaltake orbs that had that weird sort of twist design in them. And there was the Canny Hedgehog, which was a lump of pure copper. It was incredibly heavy CPU cooler, again, for its time, not my modern day standards. But you have to remember, these things were secured by hooking them onto these little plastic tabs on the side of the CPU sockets. There were no through holes in the motherboard. And it wasn't uncommon to break these tabs clean off and thus render the motherboard completely useless because you now couldn't attach a cooler to your processor anymore. So in keeping with the generic parts theme for this build, I found this thing. It's a completely boring, generic, no-name socket A cooler. Just a lump of finned aluminium with a no-name fan on top. Either that or the sticker's fallen off, but it'll do the job, it'll keep it cool, and we'll see what we can get out of it with this on. Moving on to the motherboard, I've selected this. It's a Chaintech 7AJA. Now at the time of these socket A motherboards, manufacturers would do various different things to try and stand out from the competition a bit. It could be anything from, say, lots of voltage and bus multiplier options for overclocking. It might be a second set of IDE ports for RAID, something like that. Maybe even funky coloured PCBs like what you get from DFI and manufacturers like that. I'm pleased to say this motherboard has none of those. It's another completely sort of predictable run-of-the-mill part. Again, it's not been used for many years, although it was working when I last used this. It came out of a computer that was in a garage, so it was very dusty, very mucky. I've cleaned the thick of it off, but I'm not going to go to the efforts of giving it a full clean. It's not what we're about in this video. It's slightly bent, as you can see here, but touch wood, it'll still work. Got 2 IDE channels, floppy disk, 3 memory sockets. There's our socket 462. We've got a universal AGP slot, 5 PCI slots, and the 5th one is shared with a single ISA slot. We've also got an AMR slot, audio modem riser, that stood for. I've never seen cards for these things ever sold. I've only ever seen these slots used in OEM PCs. It's a cheap way, if I remember, to add a sound card or a modem or something like that. We've got onboard sound and your usual accompaniment of other ports, PS2 for keyboard and mouse, a couple of USB ports, 2 9-pin serials and a 25-pin parallel. A lot of the optional features on this board are missing. For example, dual BIOS is missing, extra headers here, the upgraded onboard sound which went down here, none of that fitted. It's built around the VIA KT133 chipset, which will be under that north bridge there. But I'm not sure if all the features that were implemented on this board. We can definitely adjust the multiplier for the CPU. I don't know until we get into the BIOS if we can adjust bus speed or if we can adjust the voltage that we can send to the CPU either. One useful thing this does have is you may just be able to see in the middle of the CPU socket here is this little blue thing. Now that's a temperature sensor. The early Athlons and Durons didn't have any temperature measurement built into them. So if you didn't have your cooler on correctly or the fan failed, say something like that, you would burn the chip up in just a matter of seconds. Very quickly, motherboard manufacturers began to compensate for this by putting temperature sensors under the CPU socket. And if the temperature got too high, they would shut down the system. And if you were lucky, that'd save your CPU. Hopefully we don't need that while we're trying to overclock this chip, but if we do, we might just get lucky and it might save us skin. Now, as a bit of a bonus, I've noticed that some of these caps, these two in particular, this one here, are starting to bulge. This board is right at the peak time of the capacitor plague. I'm surprised, to be honest, that it's only these three. But in keeping with the theme that I'm trying to do this, we're not going to recap that or replace it. So long as it works, we'll just see how far we can push it with these already on, and we'll go with what we've got. Here's the graphics card we're going to be using. This is a GeForce 2 MX. This particular one is made by Inno3D. It's their GeForce 2 MX Tornado, it says on it. It's an MX 400. Now I'm actually re-recording this bit from sort of further in the future because this is not the graphics card I was originally going to use. I had planned to use my TNT2 M64 as I think sort of parts wise it was maybe a little more in keeping, but I was having awful problems with the system. It just wouldn't stay stable running any sort of 3D application, so not really sure what was wrong with that card, but changing it out for this one, everything worked fine. It's still in keeping with our sort of cut down middle of the road parts theme for this build. Nvidia essentially took a regular GeForce 2 and cut half the pixel rendering pipelines out of it to get these. Memory bandwidth could be a bit of a mixed bag as well depending on the bus size. These ranged anything from a 32-bit bus up to a full 128-bit bus. I'm not sure what this one has. I do know it's got 64 mega RAM on there, SDR memory, again nothing fancy since it's the cut down version. Here's the RAM we're going to be using. It's 256 megabytes of PC133. It's just one of those generic sort of no-name brand sort of value sticks of memory that you used to get. This one is at least third hand. The sticker on the back, this sticker's upside down, but this place here was a shop that sold second-hand computer hardware. My friend bought this sticker RAM from there many years ago, and then I eventually got it off him. So I'm at least the third person to own this sticker RAM. Don't know what kind of headroom we're going to have for overclocking, but we're going to put it in the system and see. Hard drive, nothing special about this. We've just got a Seagate Barracuda, 7,200 RPM spindle speed, IDE of course. I think it's a Ultra ATA 133. It's a 40 gig drive, and we'll have the OS and all the programs on here. Now in terms of a case to put all this lot in, it's got to be this, the open air test bench. I appreciate there might be some people out there who would argue that this isn't strictly speaking a case, but this is about overclocking, and this is the perfect thing for that. It's nice and easy to keep getting to jumpers and dip switches for changing things. There's no airflow problems or keeping things cool, etc. So this is what we're going to be using. It's eBay's cheapest test bench. I've not had it long. I've only used it a couple of times, but so far so good with it. The power supply is an old Chaintech. It's a 350 watt unit. Nice and reliable. There's plenty of current available on the +5 and +3.3 volt rails, which is exactly what we're going to need for this sort of system. Right, let's get it put together. We've got the CPU installed in the socket on the motherboard, but we need to just quickly talk about overclocking these Durons or an equivalent Athlon, because it's not quite so straightforward as just changing the multiplier. You see, in the previous generation or two of CPUs, overclocking had started to become more popular, and the manufacturers had cottoned on to this. Now, they decided that they didn't want people buying their budget CPUs and overclocking them to near the performance of their much more expensive CPUs. They just wanted you to buy the more expensive ones. So what AMD did was lock the multiplier of their CPUs, and that meant the only way you could overclock was by increasing bus speed. However, the motherboards of the time had difficulty decoupling the bus speed of the CPU from the bus speed of the rest of the stuff on the motherboard. And overclocking one would overclock the other. So what happened was your PCI bus, for example, would start to overclock and run faster than it should, and very quickly you'd start to get problems with your PCI cards. So overclocking by bus speed alone didn't get you very much of an overclock. Now, what people soon figured out was that the way AMD were locking the CPU was by cutting these 4 L1 bridges on the top of the CPU package. They're essentially just traces in one of the electrical circuits, and before the CPU left the factory, AMD would cut those traces and the CPU would be multiplier locked. So what you had to do was get a conductive pen or even just a mechanical pencil like this one, and use that to remake the connections across the 4 L1 bridges, being careful not to short one to its neighbour, and that would unlock the multiplier again, and you could overclock in the normal way by adjusting multiplier as well as bus speed. I don't know if I'll be able to get a good shot of it underneath the magnifier, but I'm going to use this pencil here and I'll rejoin those bridges and we'll be able to see what overclock we can get out of this CPU. Okay, as you just saw in that little montage there, we've got the system built up. The only thing I've added that you haven't seen is I've just stuck a CD-ROM drive on there for installing software. We've got this rounded cable so we get maximum airflow. And I've just stuck a little fan sat on the PCI slots, just blowing air on the graphics card, keep it as cool as possible. One thing I didn't realise just how loud the fan is on that CPU heatsink. It's a 6000 RPM fan, which is faster than I thought it would be, and it's got a really loud sort of whine to it. It's already quite fatiguing sat next to it, but at least it'll give us the best chance for a good overclock out that CPU. Everything powered up fine, no problems. I've installed the OS. I'm using Windows Millennium Edition because, damn it, I like Windows Millennium Edition. And what we're going to do now is run 3 benchmarks. First is going to be 3D Mark 99 as a sort of synthetic benchmark. Second is going to be Quake 2 running in OpenGL, and the third is going to be Unreal Tournament running in Direct 3D. I'm going to run each benchmark 3 times to get an average, and then after that we'll start with the overclocking. Right then, on to the overclocking. How did we get on with that? I started with the CPU multiplier. Its default is 7.5. No problems changing that up to 8 or even 8.5, but a multiplier of 9, the system just would not boot. I couldn't even get it past BIOS. Had to drop back to 8.5, and at that multiplier everything ran stable. After that, I tried bus speed. I'd brought the CPU back to its default of 7.5 on the multiplier, so I knew that wouldn't be holding anything back. Above the default option of 100 MHz, the next one was 102, that ran fine. But once I got to 104 MHz, which was incidentally also 35 MHz on the PCI bus, we started to get errors and corruption within Windows. A really small overclock there. Thought we might have been able to get a bit more out of that, and as I said, I knew it wasn't the CPU holding things back, so I brought the multiplier back to 7.5 just to test that. Combining the two, the 8.5 multiplier and the 102 MHz bus speed, meant we ended up with a final CPU clock of 867 MHz. Moving on to the RAM, options in the BIOS were pretty limited. I could move the cache latency timing from 3 down to 2, that ran fine. But the rest of the memory timings, you couldn't set them individually, you just get the sort of default options of slow, normal, fast and turbo and so on. Amazingly, for this super cheap value RAM, we could run at cache latency 2 and with the timings at turbo, so that was a better result than I was expecting on the RAM. Finally, moving on to the graphics card, I had a bit of a problem here. I could not overclock the core of the graphics card no matter what software I used. I tried Riva Tuner, I tried Coolbits, I tried PowerStrip, I tried NVMax. None of them would budge the core, so we just had to leave that where it was. When it comes to the memory, got quite a decent overclock on that. Default is 143 and I managed to get that up to 190 MHz. A nice speed boost out the graphics card, even though we couldn't get anything out the core. And so with all those overclocks brought together, the final thing to do was to run through the suite of benchmarks once again, and then we can have a look at some results. Okay, time for some results. Well, in 3D Mark 99 went from 3,789 3D marks up to 4,363, a 15.1% increase. And we went from 10,762 CPU marks up to 11,928, a 10.8% increase. Quake 2, that went up by pretty much bang on 10% from 74.8 frames per second to 82.3. And Real Tournament, almost the same amount, 9.9% increase from 48.6 to 53.5. So pretty consistent across the board then. The only big jump we saw was that 15% in 3D marks, but as I've said, that's more synthetic than real world, I think. But what about that as a whole? Well, to be honest, I'm a little bit disappointed in that. I thought we'd maybe be able to squeeze more out of this system. Looking at the CPU first, I thought we'd get a greater multiplier than that. I seem to remember these Durons were better overclockers than that sort of back in the day. Certainly these lower end ones having a bit more headroom. I thought we might have got a 9, maybe 9.5 multiplier, something like that. Things that are hindering us are probably these caps. As we said, some of them are bulging, they'll almost certainly be out of spec and want replacing. So maybe that was holding things back a bit. Likewise, this is old silicon now. I couldn't hazard a guess at how many hours this thing run, but it's probably getting up there now, so it's perhaps not got the overclock left in it that it once had. Another thing that held us back is that I couldn't put more voltage into the CPU. This being the budget version of this motherboard, it doesn't support it through BIOS, it has to be done through dip switches, and this budget version doesn't have those, it just has solder pads with resistors on instead. The memory, given the sort of very cheap budget nature of that stick, I wasn't really expecting anything, so the fact we managed to increase or decrease the cache latency from 3 to 2, that's helped a little tiny bit, and I did benchmark that just by itself and it showed a small increase in the CPU marks in 3D marks, so it definitely did a little tiny bit of something. And then you've got the bus speed itself. We only got that small increase, and I think we got two reasons for that too. One is probably these capacitors not helping us, as we've said before. The second is the reason that we touched on earlier in the video, whereby the motherboard can't disconnect the PCI bus from the CPU bus. So as we were overclocking CPU bus, we saw the PCI bus creeping higher and and it was going out of spec and I was getting corruption. In fact, it got to the point where in true Windows 9X fashion, it corrupted the install enough that I had to wipe the hard drive and start again. And as for the graphics card, no idea why the chip itself seems to be locked on this one. I tried about 3 different overclocking utilities. None of them would let me overclock the core. I could only do the memory, which we saw there in RivaTuner. The memory actually surprised me. To say it's only clocked at a default 143, the fact we managed to get it up to 190 was a decent overclock on the memory for the graphics card. And that, again, when I benched it just by itself, showed some increased frame rates in 3D Mark 99. So in conclusion, using these old mediocre parts has resulted in a pretty mediocre overclock. Who'd have thought it, eh? Nonetheless, overclock we did. And I hope you've enjoyed my submission into the overclocking build-off. If you put hashtag overclockingbuildoff into YouTube, you'll get the other videos in this series, and I'll bob some links down in the description too. I hope you've enjoyed watching this video. If you have, drop us a like, subscribe, a comment, etc. down below. But for now, I'm just going to say thank you very much for watching, and we'll see you in the next one. Bye bye. Oh, am I glad to turn this fan off?